Well, I thought it was a good time to actually bring out my decent constant voltage, constant current boost converter, which is running off this battery. Now, I charged up the supercapacitors through the device through my generator, which are here. So these are all charged up, and they're basically powering the LEDs through a boost regulator, which is here. Right now, I'm actually running them down slowly, which is why we have a minus. We have a minus 7.4 milliamp, and it started out at minus 28 milliamps. Now, very interestingly, when the yellow LED flashes on here, that's constant current taking precedence, which means that it's constantly current limiting the drive to the motor. When the green LED is lit, that's constant voltage, which is basically set at 13.8 volts, and the constant current is set at 800 milliamps. Now, I'm watching something quite interesting that's going on right now, because as the supercapacitors are slowly being discharged through the LEDs, my RPM is actually going up, which is not something you would expect. So, well, anyway, the RPM isn't dropping because of the way I was described in the previous video about using capacitors on the exit coil. And the more current the device has to deliver, the more the exit coils will activate to cancel out the drag, which is why it's accelerating slightly. Well, it was accelerating because there's a bit of an abnormality with this motor, this motor here, which drives everything. What I noticed with it is that the higher it gets in speed, the more current it draws, which is kind of back to front really, but it's probably not very well made or something. But as the motor increases in speed, the current goes up normally. That's why the yellow LED flickers on a few times, because it's trying to draw more current. So the constant current kicks in, limits the current, so we see a slight slowdown of the motor, and as the motor slows down, the current drops, and as the current drops, the yellow LED no longer flickers anymore, so we're on constant voltage. So what is fascinating about this configuration is the fact that as my supercapacitors are slowly discharging, my RPM is not changing. Which is really cool. Well, anyway, the current now going out of the supercapacitor is minus 4.4 milliamps. So the extra power that's been dissipated from the supercapacitor has dropped now to 4.3 milliamps, which means that most of the power is being sustained by the generator to power the LEDs. So most of the load is actually on the coils now, on the generator to drive the LEDs, and there's only 3.9, 3.8, 3.7 milliamps being drawn off the supercapacitors, which were charged up earlier. Now look, the LED for the constant current is flickering, which means that constant current is now taking precedence. Is actually, when I say precedence, I mean the constant current circuit is doing its work at this point to limit the current going out. And this is what happens as the RPM starts to climb. When the RPM starts to climb is because my exit coils are actually working. They're actually doing the job. They're actually increasing RPM as the load increases. And as the load increases, RPM goes up, constant current starts flickering, which is what it's doing now. I decided not to use that other boost regulator because it was just, yeah, it was just useless, and I thought, why don't I just use this module I was using on the previous pulse circuit I was using previously, because it's got both the constant voltage and the constant current built into it, and it's a lot better. It's easy to see what's going on. So you can basically see the voltage on the output, which is 13.8 volts to the motor. It's programmable, so I can easily program the current and the voltage, and it's a lot easier to see what's going on because you can see the LEDs flicker when they're actually taking precedence. The green is on all the time right now because it's constant voltage, but when the yellow LED flickers, the green one goes out because that's when the constant current is taking over. So anyway, it's fascinating to see what's actually going on with this. It's very interesting. We can see at the moment we're only taking 2.4 milliamps now out of the supercapacitors, which is virtually nothing now, and we're sustaining all of the LEDs. All of the LEDs are really bright. So there'll be about, what, 60 milliamps going into the LEDs at the moment. I can't show you that directly because the meter, the white meter, is connected in series with the supercapacitors, but if I was to disconnect the LEDs, you would see the amount of current that goes into the supercapacitors, which I'll do now. So if I disconnect the LED array, which is this wire here, now that's the current that was going into the supercapacitors, about 92 milliamps, and now that 92 milliamps is going back into the supercapacitors. Now let's watch what happens with RPM and we're seeing a slight increase, but obviously as the RPM increases and the current into the supercapacitors decreases, the actual counteractive forces on the exit coil will also decrease, which will balance out and basically cause more drag. Well, or actually not more drag, but it will kind of equalize itself. And no longer do we see the constant current flashing on and off, we're just seeing a constant voltage now. So yeah, very interesting what's going on. So a little update on progress. I'm waiting for some more bipolar capacitors to arrive, some non-polar electrolytics, which I want to put on my generator exit coils because I want to try some different values. I've got two in there wired back to back, and one's a non-polar, so I ideally need a whole bunch of them really. So yeah, fun, a lot of fun. My RPM is only gone up a slight amount, which is yeah, you can probably see it there. So yeah, I'll put the LEDs back on again. I want to see how, if they go down below zero really, you see. Right, so let's look at the voltage out, RPM, and the scope. And we're back down to 33 milliamps coming out the supercapacitors to the LEDs. So it's gone back up because I put power into the supercapacitors. So they're now discharging again through the LED array, and we can see the RPM is about the same. Yeah. Anyway, in the next few days, possibly 3 or 4 days, I should get the other non-polar capacitors, and we can do some more testing with different values, and I'll probably add another set of coils and we can play around with 2 outputs, see how much extra output I'm going to get for versus the amount of input. I've preset this, I've programmed it and saved the settings so that every time I connect it, it will remain on the same setup. So it will be interesting to see how much extra current I can get out, because when I actually plug this into supercapacitors, when they're actually discharged, the output, the power going into the supercapacitors is about 130 milliamps. It's actually 135, but it's slow. It rapidly charges when it's right low down. The more power's going in, the quicker it rises. So it usually goes up pretty fast, and then it slowly creeps up to a point where the supercapacitors are getting a constant 50 milliamps. I've not really seen it drop any lower than that, because what seems to happen after that is that the RPM just keeps climbing and climbing and climbing until either the constant current or constant voltage limits the speed, and it doesn't go above 6,000 RPM. It usually gets to about 5,900 RPM, 5,900, and then it usually, that's the top. That's what I've set it to, so it doesn't go any faster than that really. So we're doing really well. Actually, come to think of it, it's actually at 5,900 now. Yeah, which is actually really good news. Yeah, because it doesn't seem to go, and it doesn't seem to be having a lot of drag at all on the system. Quite chuffed about that. Trying to put my tweezers away, and I'm watching Judd Trump, seeing if he's going to beat on YouTube, see if he's going to beat Mark Allen. Allen seems to be making a comeback at the moment. Yeah, interesting what's going on here. Very interesting. As I say, my constant current. If I press the button to show you, it slows down while I'm setting it, and I don't want to do that. Well, I can do it because it always seems to slow down when I switch to constant. When I switch to the current setting, but it's set to 800. Let's have a look. 800 milliamps. Right. Right, we're at 800 milliamps, 13.5, 13.8, sorry, volts DC output. Yeah, constant current was kicking in there. Now it's staying at voltage now. So yeah, so you saw what the current is set to, 0.80, which is 800 milliamps. RPM, yeah, and our discharge current is what's coming out. Supercapacitor is 12 point something. It's dropping in milliamps at the moment. Yeah. Anyway, thanks for watching.